units, that is the present-day Diara Formation, the Kosi Formation, Purnia Formation, which is underlain by the Gothini Formation. Tributaries such as Dhemra, Beherwa, Kamla, and Satras rivers flow in the region. The drainage pattern is parallel to subparallel. Geomorphologically, 16 different geomorphic units have been identified, and six soil groups have been identified. That is the cambisols, arenosals, fluvic cambisols, and regosols. The water table lies below 5 meters in the area. Methodology. Topo sheets, satellite imagery, digital elevation model, climate data were procured. Field data was validated. Ground validation was done in November 2022. Topo sheets were downloaded from
Hello.
NASA. Three satellite imageries were downloaded, two of Landsat and one of Sentinel from the European Space Agency and USGS Earth Explorer. The main objectives of the study: climate data analysis from 1970 to 2020, geomorphotectonic assessment, land use land cover analysis and change detection from 2001 to 2020, wetland evaluation, ecological vulnerability mapping and assessment. The following methodology has been adopted for the study, where all the procured data have been combined to form the land use land cover map, and geomorphotectonic analysis has also been performed. Then a climate data analysis, along with all other data, have been combined in the fuzzy AHP method to form the ecological vulnerability map. Climate data analysis from 1970 to 2020. The temperature data was procured from 1970 to 2020 from IMD Pune. The area experiences a humid subtropical type of climate. Three seasons have been identified, that is the summer, monsoon, and winter. These are the various calculations that have been performed from the climate data evaluation. So, from the climate data, it is clear that winters are becoming milder in the region, and monsoons are becoming warmer and more intense. This is the rainfall fluctuation over 50 years. So from the rainfall data, it can be seen, and from the rainfall data calculation, that is the SPI has been calculated and the rainfall variability index has been calculated. The SPI shows that severe drought events have been prevalent in 1994 and 2008, and major flood events were present during 1981, 87, and 2020. This is the rainfall variability index over time, which shows a rhythmic drought and flood period. Geomorphotectonic analysis of the subbasin. Methodology. This is a methodology adopted for evaluation of tectonic activity in the subbasin, where morphometric parameters were calculated and then the geomorphic indices were calculated. These were combined with the ancillary data to form the tectonic activity in the basin. So, drainage morphometry is a quantitative and mathematical evaluation of a drainage basin shape, size, elevation, and characteristics. So, these are the linear parameters, the basin geometry, and aerial parameters that have been calculated. From this data, it is clear that the basin is fifth order with high likelihood of flooding. It is elongated in shape and driven by structural controls. This is the drainage map of the basin showing the stream water and the drainage density map of the basin. The geomorphic indices. Geomorphic indices are regional scale quantitative metrics which are used to evaluate the basin shape and detect structural landform variations. After evaluating the geomorphic indices, we come to know that the basin show an unstable landscape. It is asymmetric with shifting of the mainstream, and it displays tilting and ongoing structural instability. These are the various geomorphic parameters that have been calculated and mapped. The seismotectonic framework and structural control. A major fault passes through the basin, that is the Munger Saharsa Ridge Fault, and the zone lies in seismic zone 4. The basin lies in seismic zone 4 with prevalent earthquake and southern hot spring, which confirms the structural control. This is the lineament density map. Lineaments are aligned with the Munger Saharsa fault, driving river channel shifting. So this is a topographic wetness index. In flat basins, when high topographic wetness index is present and wetlands are also prevalent, then it shows that there is a tectonic setting of floodplain. It is covered by the tectonic setting of the floodplain. Now we come to the next objective: land use land cover analysis. Manual digitization was carried out in the region. Nine land use land cover category were mapped using the NRSC level 2 classification. These are the photo interpretation keys of the land use land cover categories. This table shows the area occupied by each land use land cover category. Land use land cover map of 2001, it shows that agricultural forms the heartland of the basin. Patches of uncultivated land are also present. The Kosi River flows in the western margin, and river remains the stable component of the basin. In 2010, due to drought, there was degradation, reduction in cultivated land, uncultivated land increased, sandy region also expanded in the region, and wetlands started to decline. During 2020, agriculture rebounded and uncultivated land also contracted. Settlements doubled from 2001 and wetlands also declined. This is a field photograph of the cultivated land, uncultivated land, the forest cover, rivers, sand and settlement, poker, waterlogging, and wetlands. This is a land use land cover change detection statistics from 2001 to 2020 in Kosi subwatershed. From the statistics, it is clear that the positive changes have been in the built up area, agricultural area, forest cover, and artificial ponds, reservoirs, and tanks. Whereas negative changes can be seen in the uncultivated land, marshy, swampy areas, waterlogged areas, and the sandy area. Change detection map of the region. So change detection analysis, it shows that built up has doubled from 2001 to 2020, and agricultural land contracted, then rebounded by 2020 due to agricultural policies and government policies. Forest grew after 2010 due to various government policies. That is the Haryali mission or the Jal Jeevan Haryali mission. Then wetlands shrank because of agricultural encroachment, and wetlands are taken up by the makhana and paddy cultivation, as seen by the ponds and reservoir expansion. Rivers remain the most stable feature in the basin. Sandy tracts decrease due to agricultural encroachment. Overall, we can say that agricultural land has remained the major category of the region, and urbanization has expanded steadily. Wetland dynamics. So this is the wetland map of the basin. From 2001 to 2010, we can see regions where the wetlands are being lost. And from 2010 to 2020, after reduction, they are being completely lost, the natural wetlands. So positive changes can be seen in the rivers and streams of the LULC category and artificial lakes and ponds. Whereas negative changes can be seen in the swamp wetland area and the waterlogged area. So gradual contraction of wetlands and increase in artificial ponds can be seen. Degradation is mainly due to agricultural encroachment and Makhana development scheme, that is one district, one product scheme of Saharsa. Ecological vulnerability assessment. So fuzzy AHP and ecological vulnerability assessment. In this, Chang's fuzzy analytic hierarchy process was used to integrate the expert judgment with uncertainty handling, as it gives fuzzy numbers instead of crisp values in subjective judgment. 7 ecological parameters were analyzed for 2001, 2010, and 2020. So these 7 parameters are the NDVI, MNDWI, rainfall, temperature, slope, drainage density, and land use land cover. All these were then pairwise used to construct a pairwise comparison matrix using the triangular fuzzy numbers, and weights of each parameter were then calculated. All these parameters were then rasterized and reclassified. All these layers were then combined and summed up to form an arc map to form the ecological vulnerability map for each year. This is the flowchart showing the steps involved in ecological vulnerability mapping. Ecological vulnerability parameters, 7 ecological parameters, one of which is NDVI, the normalized different vegetation index. It was mapped for 2001, 2010, and 2020. All these were then reclassified into 5 vulnerability categories. So from this, we can see that rainfall influences the NDVI. In 2010, when rainfall was very low, the NDVI also show less green patches. It is an indicator of live green vegetation. MNDWI, it highlights the surface water bodies and wetlands. All these maps were then classified into 5 vulnerability classes. This is the rainfall map. Five locations were selected, and then the temperature and rainfall maps were created for 2001, 2010, and 2020. All these were then divided into five vulnerability classes. Drainage density map of the sub-basin was also classified into five vulnerability class, and slope map was also classified. The land use land cover map was also reclassified into five vulnerability class. Then fuzzy HP criteria weighting was used. It integrates all the multi-criteria decision-making framework to overcome the limitations of rigid AHP scales. Now, this is the stepwise Chang's fuzzy extent analysis method that was adopted. This is the calculation that have been performed. Final normalized weights of each criteria were then derived. All these layers were then rasterized and then combined together in arc map to form the ecological vulnerability map. So ecological vulnerability map for 2001. So in 2001, we can see that the Kosi high vulnerability zones are confined along the Kosi River channels and active floodplains, and low vulnerability zones can be seen in the eastern parts and the northern parts. By 2010, vulnerability has substantially expanded and covering central tracts as well and adjoining rural areas. The buffer zone around the main river has also widened, and agricultural loss and urban encroachment is visible in vulnerable regions. In 2020, high ecological vulnerability is now widespread, engulfing much of the southern, central, and western parts. The only peripheral parts and northern parts show low vulnerability zones. So, in conclusion, we can say that although 50-year climate data shows rising temperature and rainfall, natural wetlands continue to shrink. This defines the wetland paradox. Human land reclamation, it overrides the precipitation. Over 81% of the basin lies below 6.2 degree and restricting the drainage across the sub-basin. It impedes runoff, water accumulation, and high ecological vulnerability zones are elevated. Multi-decadal LULC shifts and policy interventions show that targeted state policies and government policies have driven a post-2020 rebound in agriculture, forestry, and commercial makana farming, but it has directly accelerated swamp reclamation and degradation of natural wetlands. So fuzzy AHP proves that natural lowlands and human activities combined to expand high vulnerability across central wetlands. So in conclusion, we can say that while morphotectonic and hydroclimatic factors create structural baseline for vulnerability, human land reclamation force driving natural wetland decline. Thank you.
Excellent presentation. Excellent presentation, and I congratulate you for wonderful work you have done. I have got certain suggestions and a few queries. Like title, you have taken as part of Kosi Basin, and at places in the text you have written sub basin, and at other place I have seen you have written watershed. So these three terminologies, the meanings are three different things. Normally, if you will see, you have used various kind of literature from Space Application Center, ISRO, Ahmedabad, like wetland at manual you have used. You have used land use and cover manual of NRSC. I have seen that also.
Yes.
And yes,
Yes.
so these you have used, and also the Seismotectonic Atlas of Geological Survey of India published. That has also been, and district resource maps have also been consulted. So these things you have already consulted, and you have very nicely incorporated into your PhD. But the important point is that I normally go for PhD for the basic things. Like you have used the term part of the basin in the title and sub basin in the text, and at places watershed in the text for the same area.
Yes.
How these three things are different, that is area of concern. Because if you see All India Soil and Land Use Survey, which is now known as Soil and Land Use Survey of India, they have published an
Yes, sir.
atlas where they have classified the entire country's drainage pattern in different kind of hierarchies, like region, basin, catchment, sub-catchment, watershed, sub-watershed. 5 levels have been already been defined in that. And further beyond, if you want to do it, you can further classify these things into sub-watershed and milli-watershed or micro-watershed, like that. And that accordingly, you
Yes,
should
sir.
give that name to the particular that area, whether it is a watershed, it
Sure.
is sub-watershed, it is sub-basin, or it is a part of the
Micro.
basin. So that is very
Yes.
important. That should be taken into
Yes.
account
Yes,
in
sir.
future.
Sure, sir. I'll
And
take
another
it into
point is that,
consideration.
yes, please. Another point is that in DEM, you have used 6 meters, basically 6 meter range has been taken into that in digital elevation model. Why you have selected that? Is it related to the Z axis or the Z, this thing, resolution of that data? Or what was the reason why you have
Sir,
taken 6
actually,
meters resolution?
Sir, actually, when I was deriving the DEM data, I used the natural Jenks system in ArcMap because it classifies all the distinct data into a single category. So I've used the natural Jenks data
Acha,
directly from the ArcMap.
For DM, you have used which particular data?
So
Sentinel,
for source, so source, I have used Aster data,
Astra
Aster
data.
DEM,
Okay,
30 meters. Yes, sir.
Astra data, this special resolution is how much?
30 meters.
30 meters. Normally, what happens?
Yes, sir.
What about the Z axis?
Yes.
Z, normally, what happens in Cartosat 1, if you see, Cartosat 1 has got the
Okay.
special resolution of 2.5 meters. And normally, it is taken that 2.5 times is the vertical resolution. So, normally,
Yes,
if you
sir.
want to get the accuracy from Cartosat 1 data, you should have to have at least 7.5 meters interval. That is the minimum range. So, similarly, that kind
Yes,
of things are applied in other satellite data also. Anyway, this
yes,
is
sir.
my suggestion. And another is, do
Okay.
you know how to convert degree into percentage of the slope?
Yes, sir. Percentage. Yes, sir. We do it in ArcMap.
How much is the maximum percentage you find in most of these
Sir,
data?
that I have not incorporated into my thesis, but
Then you
I
have you have
am
you have
writing a paper in which
you
I
have
will.
prepared the slope in degrees, and
Yes, slope and
you
degree.
have
Yes,
at places you have used the slope in percentage. So like
slope and
one degree means 2.2%, and
okay.
45-degree means it is 100%. 90-degree means it is 200%. So maximum
Yes, sir.
slope can be 200% in the natural conditions. Normally between 200 and 0. It varies between these two variations. Anyway, this should be taken into
Yes,
account.
yes,
And
sure, sure, sir.
I am also little concerned about which particular FCC you have used in Landsat 7. Which three you have
843.
used is standard FCC. So
Yes, sir.
what exactly
Eight,
the
four,
bands
three
you have
bands.
used?
I have
Hmm?
used 8, 4, and 3 bands
Acha. Means
in Sentinel, and in Landsat I have used 432.
okay. Mhm. Acha. Similarly, you have used NDBI and MNDWI,
Yes, sir.
modified normalized difference water index, and also
Yes,
the
sir.
normalized difference water index.
Yes,
And
sir.
normally, if you see, you will find that normalized this modified normalized difference water index is considered to be better for wetland analysis. Hmm?
Yes, sir.
In comparison to NDWI. So why it is
Yes,
so?
sir.
What is the basic reason behind this? And you have used it. You have done it in this.
So,
Why? Yes, please. Please.
MNDWI I have used because it uses the shortwave infrared bands and the
Right,
green
correct.
band.
I got your answer. That is the correct answer. And normally, shortwave infrared is very good for carrying out the study related to wetland data.
Yes, sir.
And if you go to the climate data, you have used, right, starting from 2001 to 2020. Sorry,
Yes,
for
sir.
temperature data, you have used for 50 years. For
Yes, sir.
50 years, you have used the data.
Yes, sir.
What is the normal rainfall pattern? If you see over 50 years period of time, normally it is considered throughout the country that for the last about 50 years, normal rainfall has not changed. It is almost the same
Yes,
only.
sir.
in
Yes,
your
sir.
this particular area, especially in this sub basin or basin, whatever it is,
Yes,
in that it is 1300 millimeter rainfall has been considered to be
yes,
the normal rainfall in your
uh,
area. Huh?
yes, sir,
Acha,
normal rainfall.
another
So,
point, yes, another point.
yes,
Why you have considered this particular basin for study? That is my point.
yes, sir. So,
Not
Saharsa,
especially
we have
wetland. Yes, yes,
yes,
yes.
sir. We considered Saharsa because Kosi River was also flowing in the region, and it is a very popular site where natural wetlands are present throughout the area. We went
Mhm.
on the field trip and we saw a lot of wetlands, and makhana cultivation is also popular, which grow in wetlands only.
Actually,
There were
Honorable
many
Prime Minister has given a
and
lot of
studies
thrust to
taken.
the makhana cultivation in Bihar.
Yes,
And
yes,
recently,
sir.
some missions are coming up from Government of India for cultivation of makhana in Bihar. And
Yes.
one more question: could you be able to see something sort of field evidences related to Munger Saharsa Ridge Fault, which is very well established by Geological Survey of India in this area?
So sorry, sir. This was not part of my study. Yes, field
Nahin,
data
but
was very limited, and we went.
okay.
Yes, we should have done this, and we should probably do this.
Actually, normally what happens is there any
Yes,
evidence
sir.
of seismotectonic this thing or upliftment of the basin or something like that? Why? Because about 40-45 years before, we used to study that this particular basin, means this river has shifted laterally about 112 kilometers in 100 years. So that was the pattern
Yes,
that
sir.
time. And laterally east-west shifting is very well seen almost in every monsoon season. It shifts from
Yes,
left
sir.
to right to left, like that kind
Yes,
of thing
sir.
is happening. What is the basic reason? Whether it is simply the siltation in that area or any kind of upliftment of the basin?
Yes. When I was doing the geomorphotectonic assessment, geomorphic parameters were also calculated. So in those parameters, I saw according to the parameters that I calculated, it showed that the river was tilting towards the left. The basin was also tilting towards the left. So this needs more intense and thorough study. But what I found in my study, after conducting the geomorphic analysis, that the basin it shows instability. It is showing ongoing upliftment
That is what
from
I
the
was.
values
I
that I
was.
have
That is
seen.
what I was asking about Munger Saharsa ridge fault. Means
Yes, sir.
that is the effect of this fault which you are seeing in the ground.
Yes, sir.
That it is tilting
Yes,
or it
sir.
is uplifting. If you
Yes,
see
sir.
the rivers which are coming out from the Himalayas from the north, they travel
Yes,
from
sir.
north to directly south and they take a turn towards
Yes, sir.
east. In most of the rivers, you will find Yamuna is coming from north to south and turning towards
Towards.
right side, towards east. This thing. So, basic reason is that Indo-Gangetic alluvial plain is vertically uplifting, which restricts the flow of the rivers which are coming out from the Himalayas directly flow into that particular direction, but it flows from north to south and then it takes a turn towards right. Actually, there is a paper by Dr. Iqbaluddin and also by Dr. Aman Qureshi, who was DST advisor, Government of India, and they have collectively written a very important letter on this particular upliftment of Indo-Gangetic alluvial plain, and they have given a model also that is applying for the entire Indo-Gangetic alluvial plain, and your part is
Yes, sir.
also part of that.
Yes, sir. So sure, sir. I'll go through those
Hmm?
papers.
That is
Yeah, I've noted
something.
it down. Yes, I've noted it down.
So probably you have prepared many nice maps, but the ultimate my one point is that you should have to clarify, because if it is a part of the basin, then it will not be a natural boundary of your study area, because most of in geological studies or in wetland kind of studies which you have done, normally we take a natural boundary which is a watershed or a sub basin or sub watershed or milli watershed, micro watershed, whatever it may be. And similarly,
Yes,
and another point, you have prepared the geomorphological map in that area. Hmm?
yes, sir.
But in that geomorphological map, I have seen that units and features all have been categorized in the same hierarchy. like older alluvial plain or younger alluvial plain or active alluvial plain. These are basically units.
Yes, sir.
But
Yes, sir.
meander scars, meander scroll, oxbow lakes, or all these kind of things are considered to be the features. So features have to
Okay,
be
sir.
classified within the unit. So
Okay,
that
sir.
hierarchy should be. Probably you have not
Yes,
used
sir.
the manual which has been published by NRSC again for National Geomorphological and Lineament Mapping. In that hierarchy has been defined very nicely. You can take that support and improve wherever next time you are doing some kind of study in your research papers.
Sure, sir. Thank you very much. Yes, sir. I'll do it.
Anyway, your PhD work is very nice, and you have put a lot of effort. I really congratulate you, and as a whole, I personally recommend this PhD for award of Doctor of Philosophy. Thank you very much.
Thank you, sir.
Yes, please.
Habib Sahab,
Sir.
are you?
हेलो जी जी सर जी
साहब, ये ओपन वाइवा है
सर,
इसलिए जो कुछ फैकल्टी मेंबर्स हमारे आए हुए हैं
जरूर जरूर सर,
कुछ
बिल्कुल सर,
भी हैं पीजी के, तो वो लोग भी अगर चाहें तो क्वेश्चन कर सकते हैं।
प्लीज प्लीज सर, प्लीज सर,
यस यस
प्लीज सर।
आप लोग की तरफ से कोई? प्रोफेसर अतुल आदित्य पांडे जी।
Yes, sir. Thank you. Thank you, and congratulations, Adila, for a very nice presentation. And Tasneem Sahab, he has inquired from his side very relevant and significant observations related to the presentation and also the contents within the thesis. There are a few queries and suggestions from my side also. As far as the Kosi Basin is concerned, 2008 is 1 year when we witnessed a very huge deluge, and there was a breach in the embankment, and the total topography of the area was disturbed. You have categorized your observations into 3 different time scales. So before 2010, 2010, 1 to 2010, and 10 to 20, and then further. So is there any significant observations in your data after 2010? Because the breach took place in 28, we have also visited the area during our investigation. So as far as wetlands are concerned, what are your observations based on the data available? Any significant change pre-2010 and after 2010?
Yes, sir. After 2010, we have land has dramatically decreased. Uncultivated land increased. So maybe because of the siltation of the siltation from the flood waters, the agriculture has been destroyed in the area. Whereas the wetlands also were on a constant decline during 2010 period.
थैंक यू। अदीला जी, एक मेरा भी क्वेरी है, डोंट वरी फॉर दैट। ये आपने विद द हेल्प ऑफ रिमोट सेंसिंग डाटा आपने जो कोसी बेसिन का स्टडी किया, उससे जो फाइंडिंग्स मिले हैं, आपके रिसर्च का जो फाइंडिंग्स है, उससे कोसी एरिया के अराउंड के जो ह्यूमन पीपुल्स है, ये निवासी है वहाँ के, उनको क्या फायदा होगा? आपके इस रिसर्च फाइंडिंग्स है इस?
Makhana cultivation can be done in the artificial ponds only. Swamps should not be reclaimed for agricultural purposes.
अच्छा,
Yes, government is already working on
वो
that.
तो अभी आप बताए थे अतुल जी के प्रश्न पर।
Yes.
ठीक है, थैंक यू।
एक और सबमिशन था मेरा इसी में। एक्चुअली वेटलैंड, नेशनल वेटलैंड इन्वेंटरी एंड असेसमेंट प्रोजेक्ट एक डिपार्टमेंट ऑफ स्पेस का हुआ था। इट वाज इनिशिएटेड वे बैक इन 1992। पहला 1:250,000 स्केल पे हम लोगों ने पूरे स्टेट मैप किए थे, एंड देयर आफ्टर दे रिक्वायर्ड 1:50,000 स्केल मैपिंग इन 2007-8, and then Supreme Court, there was a case in the Supreme Court. PIL was filed in Supreme Court, and Supreme Court given directions that you should again map and try to find out how much change has taken place in the wetlands throughout the country. And then that task was given for Madhya Pradesh to us, and we mapped that on 1:50,000 scale, and we compared that 50,000 scale which was mapped in 2007-8 with the 50,000 scale which was mapped in 2017-18, and tried to find out how much change has occurred in wetlands. So, and basically 3 parameters were identified. That is my submission, that you further, if you do the work in this particular wetland study, you use this thing, because they have given us the task that you have to find out each wetland, the turbidity index, then vegetation, floating vegetation on that, and then water spread pre-monsoon and post-monsoon. And based on that, you can find out what is the utility of that particular pond. This came into my mind by the question which was asked by my previous speaker, questioner. He asked that whether it is directly related to the benefit to the people of that particular area. So ultimately, if you will do that kind of study, you will come to know that in which particular area this can be used in the study. Yes, so sir, that is very good. Means turbidity mapping, then floating vegetation, and then pre-monsoon, post-monsoon water spread. And then find, ultimately you can come to the conclusion that this can be used for this particular study or this particular utilization. So that is my submission. Please go ahead.
Thank you very much, sir.
अब एग्जामिनर की इच्छा से हम लोग कंग्रेचुलेट करें सर.
सर so kind of you. Thank you very much. बहुत बहुत बधाई सर, बहुत बधाई, बहुत धन्यवाद, बहुत बधाई. Heartiest congratulations, Mrs. Adila, and definitely a nice supervision by Dr. Sayema, and exactly many important parameters have been incorporated in this, and I really congratulate to the supervisor also, and to the head of the department, and to the entire faculty of Patna Geology department. Thank you very much.
Thank you very much, sir. Thank you.
Thank you.
Good afternoon, everyone. May I intervene for some?
Acha, Javed Sahab, Akram Javed Sahab is also joining. Yes.
Good afternoon, everyone. With the permission of the
Yes, sir.
Patna University and Department of Geology, I would like to thank Department of Geology, Patna University, for giving me access to this excellent PhD Viva of Adila. And let me introduce me. I am Akram Javed from the Department of Geology, AMU, and I happen to be the supervisor of Sayema Jamal.
Yes,
so it's a very special day for me that my student is getting a credit of Ph.D. She has supervised a very wonderful work in the form of this particular study on Kosi Basin. So it's a very special day for me. I'm excited here, and congratulations, Adila, as well as Sayema, for the excellent study done. And thank you very much, Sayema Jamal, for your very in-depth analysis of the thesis. You have read, I think, each and every page of the thesis with the suggestion which you have made were quite useful. And I do believe that Adila in future will incorporate those suggestions for publication in the research papers. So once again, I thank the Patna University, Professor Pandey, other senior officials, Habib Saab, Taslim Bhai, my elder brother, and Sayema also for inviting me for this. Thank you very much, and congratulations.
Thank you very much. So kind of you, sir. Thank you.
Hello, Akram sir.
Yeah.
Can you hear me?
Yeah, sure.
Please put on your camera, sir. Please put on your camera.
हाँ, आपकी खूबसूरती नहीं दिखाई दे रही सर. Great.
Thank you, sir. Nice to see you, and thank you for connecting with us today.
Thanks.
I'm so overwhelmed.
Congratulations.
Professor Akram Javed Saab is a very senior professor from AMU, and he is the person who initiated remote sensing in Ecological University, and about 40 years before he started that.
That is
yes. Okay.
So once again, thank you all, and again congratulations.
Thank you very much.
Thank you.
Thank you.
तस्लीम भाई कभी अलीगढ़ भी तशरीफ लाए?
जी मैं आऊँगा सब आता हूँ जी बिल्कुल सर बहुत शुक्रिया.
Okay, sir, we'll miss you over a cup of tea, sir.
हाँ वही मैं सोच रहा हूँ क्या किया जाए हम लोग यहाँ अलग अलग पी लें क्या आपने
I will send something personally, sir. Sir, Patna आइए, sir, please आप लोग,
जी
whenever you have time to
please.
visit us.
Thank you very much.
Thank you, sir. Thank you, sir.
Okay, bye.
Can we quit now with lots of congratulations to the supervisor and to Adila?
Thank you.
Thank you, sir. Thank you, sir.
Okay, actually there was I came to the office and I am sitting in the office itself. Another National Space Day program is going on and I was invited there also, but I skipped that. I came here a little early and I slightly attended that program and also come back here to attend.
Thank you for such precious time, sir. Thank you for your precious time.
So nice of
Thank
you.
you. Okay, sir. Okay, sir. Bye.
Okay, bye bye.
Thank you, Atul sir.
Atul sir. Okay, sir. Atul
Thank you,
sir.
sir.
Shall we sign off now?